In this lesson, we're going to take a look at two population proportions, claims dealing with them, specifically using the P-value approach, using the TA3, TA4. Now, a sampling method is independent when the individuals selected for one sample do not dictate which individuals would be in the second sample. Sampling method is dependent when the individuals selected to be in one sample are used to determine the individuals in the second sample. Dependent samples are often referred to as matched pairs. It is possible for an individual to be matched against him or herself. Now, sampling distribution of the difference between two proportions. Suppose a simple random sample of size n1 is taken from a population where x1 of the individuals have a specified characteristic, and a simple random sample of size n sub 2 is independently taken from a different population where x sub 2 of the individuals have a specified characteristic. Nothing exciting there. It's just telling you you got two populations and two samples. For example, maybe Class A has 100 people in it, and you take a sample size of 35 from within that class. Well, N1 would be how many we're talking about, the sample size, and then the X1 would be whatever we're studying. Maybe we ask them if they believe in UFOs. So a yes or no type of question. And then let's say I have a second class, and its class size is 500, and I take a sample from within it of 40 people. So n sub 2 would be 40, and then x sub 2 would be again what I'm studying. Now the sampling distribution of p hat sub 1 and p minus p hat sub 2. So we're finding the difference. So that's what we're analyzing. Where p hat sub 1 is equal to x1 over n1 and p hat sub 2 is equal to x2 over n2. We've seen this formula before. P hat is equal to x over n. Is approximately normal with a mean of that's mu sub p hat sub 1 minus p hat sub 2 is equal to p sub 1 minus p sub 2. And standard deviation equal to the square root of p1 times 1 minus p1 over n1 plus p2 times 1 minus p2 over n2, provided that n1 times p hat sub 1 times 1 minus p hat sub 1 is greater than or equal to 10, and that same thing for the other population sample. And each sample size is no more than 5% of the population size. Okay, now if we were doing it by hand, then here's how we switch it to a Z-score. Now it looks like a hideous formula, but you'll find it's really not that bad. The p hats are x over n, so we need x and n from each sample. And then p1 and p2 would be our population values, and those usually are given. Oftentimes they're given as percentages, and you have to change them to decimal. Okay, now to do claims, hypothesis testing, about the difference between two population proportions, some requirements have to be met. There are two simple random samples that are independent of one another. Each population is at least 20 times as large as the sample drawn from it. Now these requirements are unique to this particular textbook. I've seen different ones in different books. This would imply that if you had a sample size of 1, then your population should be 20 times as large. But there will be another condition later on. So it says the individuals in each sample are divided in two categories because proportion is like a yes or no type thing. Do you believe or do you not believe? Do you vote? Did you not vote? Type of deal. The both samples, and we're very black and white on this. There's no in between on that. Either you voted or you didn't vote. Both samples contain at least 10 individuals in each category. So even though up above we say that the population is at least 20 times as large as the sample drawn from it, we also say both samples contain at least 10. Now here's the classical approach, TA384 for independent sample. And it's also called a critical value method in some books. And we're not going to use this in this video, so I'm going to skip over this. Here's how to do the classic approach by hand with the independent sample. There's page 1 of it. And here's page 2. And again, we're not going to do it. This video is focusing on the p-value approach using TI3, TI4. So here's the one we're going to be using. P-value approach, TI384, independent sample. Step 1, write down a shortened version of the claim. Step 2, come up with a null and alternate hypothesis. H0 always has the equals part on it. Step 3, see if your claim matches H0 or H1. Step 4, find the p-value. We're going to use 2-prop z-test for this. And then step 5, if your p-value is less than alpha, reject H0. If your p-value is greater than alpha, accept H0. And then determine the claim based on step 3. Now I use the word accept here, but most books use the word do not reject. Accept is a pretty strong statement, and a lot of them don't take that. They use the do not reject, which isn't exactly accept. It just says we don't reject it. I found that students click better when they're first learning these concepts to use accept and reject, since they're exact opposites of each other. Okay, and we're not going to do it by hand, so I'll skip over these steps. And let's look at this example. Okay. Well, there we go. If I get my pen to work here. Be one of those mornings, I think. Okay, problem number 1. In testing a new drug, ZScore, I made this up, there was a concern of migraines occurring during usage. 300 out of 1,000 people in the ZScore group. Okay. So we got the ZScore group. And experienced migraines with 250 out of 1,000 in the placebo group. So we're going to have the placebo group. It's always a good idea to go through and identify the 2 different groups you're talking about. Okay, let's write down our claim. Is the proportion of people getting migraines greater for those taking ZScore than those taking the placebo? Okay, so our claim is that the proportion of ZScore is greater than the placebo, the proportion of placebo. Okay, now on these, on my claim, since the ZScore was first, I'm going to label that as my first population, first sample. And since the placebo is second, I'll label that as my second population, second sample. So over here, the ZScore is going to be our first, and then this placebo will be our second. I try to always follow that format. Is I write down my claim, and whatever's first here is what I specify as my first population, first sample. So let's read the problem again. Okay, 300 out of 1,000 people in the ZScore group experience migraines. So 300 would be our X1, and our N1 would be 1,000. Reason why I say this is X1 and N1 is because I said this is my first population, first sample. Now our placebo. It says, while 250 out of 1,000 people in the placebo group. So X2 would be 250, and N2 would be 1,000. Okay, and then it says alpha is 5%. Okay, so that's all the information they give us. And if we go back up to our steps. Step 1 was write down a shortened version of the claim. Well, we did that. Now keep in mind, I said ZScore here, but we said that was our number 1. So really, this says P1 is greater than P2. Okay. Step 2, come up with a null and alternate hypothesis. H0 always has equals part on it. Well, the greater than would go on H1. So that's P1 is greater than P2. Now these are opposites of each other. So if that's greater than, this is going to be a less than or equal to. Most books have gone to a convention where they just put an equals here. But this is the way I learned way back when, and it's hard for me to break. I like to think of these as opposites of each other. I think clicks better with students. You get the same result. Now, step 3. See if your claim matches H0 or H1. Well, we got a greater than here. That matches H1 because they're both greater than. Okay, we're going to use 2-prop z-test to find a p-value. So 2-prop z-test. So let's go to that on our calculator. Okay, so I'll do stat, go over to tests. I want 2-prop z-test, which looks like number 6. I can either just type 6 to go to it directly or down arrow to it and press enter on it. Now the x1 we said was 300. N1 is 1,000. X2 is 250. N2 is 1,000. The symbol on H1 was a greater than, so I want the greater than highlighted. Mine's already highlighted, but if yours isn't, you right arrow over to it, put your flashing cursor on it, and press enter one time. And then I'll down arrow to calculate and press enter. And we got P is equal to 0.0061. Okay. Back to our steps here. It says that p-value is less than alpha. Alpha is 5%. P-value is 0.0061. It's obviously less than. So that says if p-value is less than it, we reject H0. Which means H0 and H1s are opposites of each other. So if I reject H0, that means I accept H1. And since our claim matches H1, whatever we say about H1 is what we say about our claim. So we accept our claim. And again, some books won't use the word accept because that's pretty strong. It'll say do not reject the claim. I think I got another example here. There we go. So let's take a look at this one. In 2008, a study was done asking 500 people if they read at least 2 books a year. 20 responded yes. In 2012, a study was done asking the same question. So it looks like we're analyzing 2008 and 2012. Okay, now let's look for our claim. That helps you determine which one's your first population, first sample. Okay, are the proportions different at alpha is equal to 10%? So they're saying that the proportion at 2008 is different than the proportion at 2012. Now the different is set up differently than greater than or less than. It doesn't matter which one's first, but this is what I chose. So I'll say this is my first population, first sample. This one will be my second population, second sample. So 2008 we said is 1 and 2012 is 2. Okay, let's go back and write down the information then. Okay, in 2008 a study was done asking 500 people if they read at least 2 books a year. 20 responded yes. So 500 is N1. And X1 is going to be 20 responded yes. Now for 2012, it says asked 800 people, 45 said yes. So 800 and 45 said yes. Alpha is 10%. Okay, now we're ready for our steps. Step 1, write down a shortened version of the claim. And we did that. And keep in mind, when we say different, we're talking about the symbol not equals. Okay. So come up with a null and alternate hypothesis. Well, we got a not equal to, that goes on H1. And I'm going to say P1 is not equal to P2. Instead of putting the years there, I'm just going to put the number with a P. Now, if that's not equal to, then this will be equal. Step 3, see if your claim matches H0 or H1. not equal, not equal. So it matches H1. And we're going to use 2-prop z-test again to find the p-value. So let's go type this in. So press my stat, go to test. 2-prop z-test is number 6. I'll go ahead and press 6. X1 is 20. N1 is 500. X2 is 45. Oops. N2 is 800. The symbol on H1 is a not equal to, so I want to put my flashing cursor on not equal to and press enter. And then choose calculate. And we get P is 0.1909. 0.1909. Okay, now back to our steps. If p-value is less than alpha, alpha is 10%, p-value is greater than. So it says if p-value is greater than alpha, accept H0. So for conclusion, we're going to accept H0, which means we'll reject H1. And since our claim matches H1, whatever we say about H1 is what we say about our claim. So we'll reject our claim. Now, what you'll find is that if you got p-values that are very large or very small, they tell you like the significance. We say we rejected, but was it a close call type of deal? Well, you see, this is p-value is 0.1909. So it wasn't close to the 0.10. So it kind of gives you an order of magnitude. I guess you can think of it that way. Okay. Now those are claims. Now if I have confidence intervals, this is the formula for doing it by hand. We're not going to do it by hand. And I got a little typo in here. The point estimate should be lower bound plus upper bound divided by 2. Unfortunately, this has been corrupted by the new version of PowerPoint. I can't change this. Or maybe it's a new PowerPoint going back to the old version. But anyway, what we're going to use is 2-prop z-ent. Okay, so let's take a look at an example of that. Start a new page here. And it says, if I can get back there, in a poll of 1,000 men, 200 said they believe in UFOs. In a poll of 780 women, 100 said they believe in UFOs. So we got men and women. Construct a 95% confidence interval for the difference between the two population proportions. And they're telling us put P sub men minus P sub women. The only reason we wrote it that way is because men was first here and women was second here. So the order you run across it in the problem, you can think of the setup in that manner. Because it doesn't say. It just says the difference between the two population proportions. Okay, so I'm going to specify the men as our first population, first sample. And the women as our second population, second sample. So we're going to have X1 and N1 here. And we'll have X2 and N2 here. Okay. So 1,000 is N1. And then 200 men said they believe in UFOs, so that's X1. For women, we talked to 780. That's N2. And 100 said they believe in UFOs. And we want to construct a 95% confidence interval. Okay, so let's go to our 2-prop, what was it? 2-prop z-ent. So I go to my stat, go over my tests, and want to choose 2-prop z-ent. Which is there. Now it's asked us for X1, which we said was 200. N1, which is 1,000. X2 is 100. into a 780. The sea level is our 0.95. And then we'll choose calculate. And we're going to get, get my pen to work. There we go. 0.03766, comma, 0.10593. And that would be our answer. Now this is a 95% confidence interval, the difference between men and women. So we're subtracting these. This isn't like these combined together. It's the difference between them. Now if I said the difference between women and men, then I would flip these around. And while it seems like a small difference, it actually does change numbers. Let me demonstrate that. If I come here to stat and go to tests, and we want 2 prop Z-end, let me instead put the women values here first. So I got 100 and 780. Then I got 200 and 1000. And it's still 0.95, and then calculate. I notice we come up with negative values here. So again, it does make a difference, the order. And this problem here did not specify really an order. They said the difference between the 2 population proportions. And I specifically told you in this problem to find the difference between the men and women, which gave us this value. But if we switched it around and said we're finding the difference between the women and men, well, then we'd get these. And again, you maybe look at that and say, well, that doesn't make any sense. But realize that if we had, and this has nothing to do with this problem, but if I had 50% men, and let's say the 20% women, just dealing with the straight numbers here, if I found a difference between men and women, that'd be 50 minus 20 equals 30. But if I found a difference between women and men, we'd have 20 minus 50, which gives us negative 30. Now that's an oversimplification of the idea, because you notice that these values here are kind of flipped around. That's negative 0.1059, and this is negative 0.0377. But you kind of see the idea behind it. And that's that lesson.